to the tables, please?
I did. That's true. She was no, it was her. Someone got in without ID and then they didn't want to let her. Just went in for the crowd.
Better?
Yes.
Perfect. All right. So I'd like to welcome everyone to the October evening ASHRAE meeting. Thanks for taking the time to come out and attend. We'll start the business session by introducing the Board of Governors and the exec. There's a number of them who can't be here today. Richard Cameron is on the board, but he is not in country. Chris Frawley is on the board, but he's not here. Dan Redmond is on the board, but he's not here. Chris Fudge is on the board, and he is here. He's big enough to make up for two. Darren Dobson is here, and he's big enough to make up for two, too. We have Adam Graham, who's the secretary. Here somewhere, I'm sure, just at the back. Abby Saunders, who is our treasurer. George Mamari, who is the president-elect. Rod Potter, who is our past president. He's not here as well. And I'm Steve Moons, your president this year. So to start, we'll have Adam Graham come up to the front and introduce our guests for the evening. So if he can come on up.
I think my list might be a little light here. Oh, wow. Welcome everyone. Just like to run through our guests and welcome them to our chapter meeting here. So first up I've got Papnudi Mikkel, Tiwa Lawal from Carleton, and Paul Brisson from Dilfo. So welcome everyone.
Adam, before you go, while Adam's here, we have our first seminar for the season coming up next month. Adam's been doing yeoman's work to get it organized for us, so it is open for registration. I'll let him tell you a little more about the details.
Okay, well, on November 12th, we're going to be having a full day pumping seminar. So it's going to be on basically water system design and applications involving, it's going to be the first part of a two-part series. And we're going to try and run that second part either later this year or early next ASHRAE year. And the first part will be mostly on pumping, pump construction, pumping system design, some details on expansion tanks, locations, I think it's going to be of great value for junior engineers. So if you can get your junior guys signed up or get them some interest in it, I think it'd be great. So hope to see you all out there November 12th, and all the details will be in the communique as well as the previous one. So thanks.
Great. Registration for that can be accomplished online with our online registrations, where most of you signed up for this evening's program. One of the tabs there is for the seminar. If anyone has any trouble with it or needs to register in groups, then you can contact anyone on the board directly. Next, I'll ask Adam Moons to come up, our membership chair, and welcome the new members.
Thanks, Steve. 4 new members to announce for this month's meeting. Miss Céline Baribeau, Mr. Ryan Dickinson, Mr. Rene Dubé, and Dr. Lebing Yang. Those are our 4 new members. While I'm here, the ASHRAE bowling night is on Wednesday, the 19th of November. We've got a bunch of teams signed up already. There's still some spots available though. Again, available on our online registry through the ASHRAE website, the ASHRAE Ottawa-Valley chapter website. So make sure you get your teams signed up. It's $200 per team, and that includes your bowling, some food and snacks, and an opportunity for a coveted trophy. So be sure to get yourself signed up, get your team signed up, and move along. Thanks.
Thank you. Tonight's theme is students. We're back at Algonquin, which is going to be our home for the rest of the ASHRAE season. We're privileged to get the fruits of the labor of the students here at our tables in a few minutes. But I'd like to ask Adrienne Mateni to come up and have a quick chat about our student chapter.
All right, so for students, we've got the Carleton chapter, who we've got a couple people here today, but they're doing very well this year. We've got a meeting coming up, and we also have a career panel, which we're going to have people, I have asked a number of people here to come out and just talk about the different options of careers in our industry. So we'll be having that this year, this month, and then we're getting the Algonquin, chapter started up, and we have an Algonquin project this year, and Chris Frawley is generously donated his time again to mentor them again this year. So that's going on right now.
Thank you. And sort of in conjunction with that, Joe Della Valle is our YEA chair, and he's got an event coming up as well, so Joe will tell you all about it.
Hi everyone, my name is Joe, for who don't know me. On the 30th of October, we're going to have a YEA event at Tailgaters. Whoever likes pool, come on out. It's just a social event, so guys, I don't know if you've all seen the email, but basically what I want is anyone that's, even if you're over 35, come on out. Try and bring a younger person from your office. You know, we're trying to get as many people out as we can, just to see anyone who's not a member, trying to get them involved. It's sometimes a little difficult, they don't really know the benefits. So anyway, next Thursday, not this Thursday, next Thursday from 6 until about 9, sign up online. I'm going to send another reminder out probably later this week to get everyone to try and get registered online. So anyway, thanks, and I'll hopefully see you out.
Thanks, Joe. A big part of what ASHRAE Ottawa-Valley tries to do is encourage the social aspect of our get-togethers. The bowling is the next one that we have coming up. Yay is a component of that. And the last one that we had was our stroke play tournament, which was held end of September. We had a pretty reasonable turnout. I think we had 12 guys come out and smack the ball around. New champion this year, which I'm sure makes Mark green with envy. But Peter Nabby with the Ottawa-Carleton District School Board shot a 76 to Ed Cassidy by 1. So he is the reigning champion and will be happy to defend next year. Anybody who's interested, keep an eye out in the next summer for notice on that. One thing that we started again this year, we've been a little bit remiss in the past year is our technical sessions. We were fortunate enough to have our meeting initially in September at Nortec's facility. They put on a bit of a presentation on humidity and what it means. We had a second one today on compressor technology. I gave the presentation. It was just a brief overview of the different types of compressor technology, what's, quote, new or what's currently available in equipment, how it interacts with different types of refrigerants, and what the aspects are to be considered. So I have that presentation. Anyone who wants to get their hands on it, they can contact me. I'm happy to distribute it. There's nothing proprietary or specific to any one manufacturer on it, just general terms, and I'm happy to share it as you need. Other than that, we have our tabletops to discuss before we get to the meal. So first of all, I'll ask Chris Foot to come up and tell us a bit about data air.
Tonight we're featuring Data Air. The Master Group is now the official representative of Data Air in Eastern Canada. For those of you who are not familiar, Data Air is a manufacturer of precision air conditioning equipment. And some of the new features that we're bringing out are plenum fans, ECM fan motors and supply fans, as well as variable speed compressor technology. Data Air is incorporating this technology into both in-row cooling, as well as your traditional standalone craft units for underfloor or overhead applications. If you have any questions, we'll be hanging around the booth a little bit later tonight, so please feel free to stop by. Thanks.
The second tabletop that we have is a pool pack, and I'd ask Andrew Duma to come up and tell us a bit about that.
Yeah, Total HVAC is very pleased today to be showcasing Poolpack International, a quality manufacturer of pool dehumidifiers since 1973. A few newer technologies, I guess, that we're kind of showcasing a bit today. It includes double wall construction with direct drive plenum fans, and the VHR ventilation heat recovery unit, which is a non-compressorized unit. So feel free to stop by at the booth, say hi, and learn about some of the new technologies that we're presenting today.
Great, thanks. And lastly, we have Kevin Quinlan, who's here with Hydro Ottawa. A number of you probably know him from rebates that you negotiated with him on various types of projects. But I'll ask him to come up for a quick minute and just give us a rundown on where Hydro Ottawa sits with those items currently.
Thanks, everyone. For those who don't know me, again, my name is Kevin Quinlan. I'm with Hydro Ottawa. I work in the Conservation Demand Management Group, and our whole, pretty much, role, we provide incentives to all of our commercial clients when they're putting out energy-efficient equipment into their buildings. And I'm proud to say that over the last 4 years since this iteration of the program has been going on, we've paid out more than $10 million here in Ottawa, excuse me, for a lot of our commercial customers. And the nice thing is I can announce today is that we are now aware that the program is going to move forward for the next 6 years. So what I would like to be able to do is, if you've got questions, I have a booth. Certainly what would be nice is, I'd like to be doing more business with this particular chapter of ASHRAE. I know a lot of folks here that I have been doing business with over the last few years. It's been very successful. I think we've helped a lot with a lot of the projects that you've been working on, and certainly moving forward, we'd like to do more. So, as I say, it's going on for 6 years. We're over here, and by all means, I'd be more than happy to answer any questions. Thanks.
So that sums up our technical or our business session. The food will be served shortly. We'll have our presentation start closer to 8 o'clock. In the meanwhile, I'd ask all of you to keep an eye out for George Momari, who is continually circulating with Sense tickets. The raffle will be held just before the evening presentation. George is a friendly guy, and he will happily take your money. Enjoy your food. I'm doing all I can. Hopefully all enjoyed your meal. I'd like to thank Algonquin for a really nice presentation. Again, this is the first time out for the students with us this year, and I think they exceeded our expectations. They continue to do that. I'll get, let's see, we'll bring up our guest speaker up, Mark Politza, to make the draw for the Sens tickets. So if you want to come and help me out.
Let me get my card.
All right, so before I announce the number, this is something that we've done all last year and we're trying to do again all of this year. Different contractors, suppliers, consultants in town have been really generous to donate Sens tickets, Red Blacks tickets at no cost to us. It lets us raffle them off in a situation like this, raise all the money for research promotion to try and reach our goal. George Murray is working really hard to get to $25,000. We're off to a really good start. This month, Engine Adair donated 4 level 1 tickets plus a parking pass for the Sens game this Saturday. So it's donations like that and from people like SK and Direct Energy that really make our research promotion goals much more manageable. So thanks very much to everybody who's donated those tickets, and we'll be able to do that every month this year. So without further ado, the winning ticket is 0758337. 8337. No, I'm not kidding. Sure. Come on up. Hey, you told everybody. All right, so we'll go to the evening presentation. We had a different topic originally for tonight, but our speaker had to cancel with a couple weeks' notice. Fortunately, we're really lucky to have a number of people in town who can pinch hit for us in short notice, and one of them is Mark Politza. He's with Soresco here in town. We were joking earlier on, normally he's out of town doing this presentation for other people's ASHRAE meetings, and so we got to have him stay here for some home cooking and give it to us tonight. So without further ado, I'll bring up Mark and he'll tell us all about natatorium designs. Mark, come on.
Great, thanks very much. Guys, can you hear me? Or do I have to use a microphone? We good? We good? Yeah? Okay, good. Okay, so as we go through this presentation, right, the best time to ask a question is when it's in your head, right? Don't wait for a couple slides, right? I can go backwards, forwards, up, down, you know, you name it. Just ask the question. We'll have a little bit more fun, keep it a little bit more interactive. Okay, everything that you're going to see in this presentation, you know, is available online, a whole bunch of different sources. You'll find a lot of stuff in ASHRAE as well. As a company, we support ASHRAE. It's very important to us. Obviously, it's a niche industry. All manufacturers really should be, you know, using ASHRAE to get their message across on how applications should be done. This presentation is no different than that. Okay. You know, we're just going to keep going on this part. Let's just start with the with this part here. For the Americans, I always like to say this is the shock and awe portion of the presentation. Okay, this is when things go bad. This kind of focuses you on how to do things right. Now, reality is, and you'll see by the time we get to the end of this presentation, you'll see there's 5 or 6 things that we really have to do, right? But what we're not talking about here is not brain surgery. It's all pretty easy. So follow the rules, you have a good job. Obviously, I'm completely biased, but pool work is a lot of fun, okay? Not so much in this application over here. Now, this is ironically, a fun park in Moscow. Outside shot. Yeah. So this is an outside shot. You can see the snow and everything. This is a total, utter structural collapse of this natatorium. You can see it here during the daytime. 22 people died. Okay. This is all because there was no vapor barrier in the walls. Can anybody answer one simple question? Is a suspended ceiling a good idea for an indoor pool? I mean, you can't say yes, even if you don't know what you're talking about, right? You can't say yes to that question. Now, if you're looking for the pool, it's over here, right? There were actually 2 people swimming in the pool when this happened. Now, it doesn't normally happen this way, okay? This is a little bit of an anomaly. When they put in the suspended ceiling, and yes, it is a bad idea, but when they put in the suspended ceiling, they said, hey, this is a pool, let's do the right thing. These stainless steel tie-offs that you normally get, or galvanized steel tie-offs, they changed to stainless, thinking they were doing the right thing. Now, one thing that most people don't realize is stainless steel is just about biodegradable in a pool, okay? Your gut would say that that would be your go-to metal to use, right? Your gut's wrong. Stainless doesn't do well at all. So, especially under tension, and of course these are all under tension, as they started going, one after the other, all of a sudden, boom, this thing came down in one shot. Probably made for some great stories at home, but nobody was injured. I'm actually not even sure where they crawled out of the pool. This is just like out of control. This last one here is a phenomenon known as efflorescence, okay? And again, what we're talking about is no vapor barrier in the pool. Moisture is traveling through the wall, and when it hits the outside of the wall, it's evaporating. Now, as moisture is traveling through the wall, what's really happening? We're talking about water in its pure form. Hates to be in its pure form. So of course it's absorbing minerals from the brick and the mortar. When it evaporates off of the surface, it leaves all this behind. You've probably gone by some building where you see these telltale shadows of exactly this. Now this is an end stage wall. This is actually quite advanced. You can take a plastic pen and you can dig the mortar out from in between the bricks. It's that weak. So this is a really old picture. This is in a dumpster somewhere. Okay. So, what's the right relative humidity to keep a pool? Now this is a chart that's used by many, many different companies. And the reason why it's pretty relevant, because it tells us under which relative humidity, right, different substances that affect human health and welfare thrive. So if we take bacteria, you can see at the low relative humidity, it's thriving, and at the upper relative humidity, it's thriving as well. So what we come out to is a optimal zone in between here, between 40 and 60%. Now, by default, because everything is thriving at the lower and the higher, this is going to be the healthiest for us. Now, as a pool, you don't really want to drive the relative humidity all the way down to 40%. The reason being, if you do that, you're increasing the evaporation of the pool as well. It now becomes more expensive to run. So we try and focus on the 50 to 60% portion, okay? And that helps to get a good balance in between things here. A couple of things that we're going to rip through in this presentation here. You see it's going to go quite quick. Hopefully it's going to also feel like it's going quick. Right? So let's start off with the dew point. When we're doing a design, you have to know what dew point you're going to be running at, because everything revolves around that, of course. So a typical pool temperature would be around 82 degree air, 50% relative humidity. That translates to 62 degrees dew point. Why do we care what the dew point is? Absolutely, right? Anything that's below that temperature will have condensation on it. And that's obviously something that we want to control and get rid of. We also need to know why water evaporates. And it's basically the vapor differential between the water and the dew point of the air. Knowing this, we can also control this as well, which again, hopefully by the end of this, we can do the dehumidification or the control of this indoor pool more efficiently and with a little bit less dollars. So the evaporation rate calculation, in its distilled form, this is actually the ASHRAE formula, distilled down. There's a couple of things that we need to know. There's a constant here. We need to know the area of the water. So we care about the surface area. We don't care if it's 2 inches or 200 feet deep, right? We care about the amount of water that actually sees the air. That's going to affect the evaporation. We also need to know the vapor pressure differential. We get that by knowing pool water temperature, air temperature, and the relative humidity set point. We can get those two vapor pressure differentials from that, and we can carry on with our calculation. The only thing that's subjective in this whole thing is the activity factor. Now, if we think activity factor is exactly that, right? The factor that we put on based on the activity of the pool. Now, if you think about it as a multiplier on the area, think of completely flat water, and then think of a whole bunch of kids jumping in, you know, and making that water move. Now all of a sudden, what's the air seeing? You're seeing more water in effect. So the activity factor is, and don't forget, it's important, the activity factor has to be an average of the total body of water. Okay? So it's basically just a factor on the movement of the water. Now, these are really easy to come by. Those have been hammered out for the last 30 years, right? Probably the only thing that every manufacturer can actually agree on. So, when we decide on what the evaporation of a pool is going to be, we usually profile a pool in 2 different ways. During active and then during non-active hours. Non-active hours, right, we say an activity factor of 0.5. And a 0.5 is your baseline. That is completely flat water. It's obvious that an activity factor can never go down to 0, because if you place a 0 in this equation, you've got 0 pounds of water being evaporated per hour, which is obviously never going to happen, right? There always has to be something in that equation. So a 0.5 is completely still water. And then we say, whatever our set point is going to be, and typically it's going to be 50%, right? That's the industry norm. We're going to say at 50%, what's the evaporation rate? Plug it all in, and there we go. And then we turn around and say, okay, but during the day, right, our activity factor is going to go up. This happens to be activity factor of a very active pool or a whirlpool even. Okay, so we're talking about a lot of activity. A rec center, you know, a place where there's lots of kids in it. Pretty common. And then we're going to say, we're going to allow it to go up to our high relative humidity point. Now, the reason why we allow a span between 50 and 60% is because if we just said 50%, that's it, I don't want it to go 1% higher than that, your equipment is going to be huge. Okay? You're going to be probably throwing 3 times the amount of tonnage at your pool. And of course, it's going to get really expensive at that point. So we say between 50 and 60, even though the set point is really at 50, what we're saying is, we look at this amount of humidity that's coming off that pool, and we allow it to balance, right? So your compressor is running and chewing away at the humidity and everything, and at around 60%, that's where it's going to balance and it's going to go no higher. Okay? Kids start getting out of the pool becomes a lot less active, and it brings it down all the way to 50%, compressor shut off. Right? And those are the normal cycles of a pool. And again, by allowing this spread, you can reduce the equipment size. Okay? Very important. Any questions so far? Okay. A lot of different types of pools. Lots of typical pool air and water temperatures, and also activity factors. Now, the reason why I say typical, and the thing that I always really try and get across on this slide here, is that you need to understand your owner's expectations. Okay? If you look at, you know, a block in here and say, okay, well, I'm just going to punch in those numbers, and trust me, it happens every day. But the people that own that facility turn around and say, no, no, no. And of course, they're going to say this after the equipment is in, right? I want a completely different temperature. Well, the equipment might not function the way you wanted it to, okay? And in this industry, you know, a couple of 3 degrees makes a big difference in the equipment size you would have selected. So it's important to understand what they want and make sure that you're giving them, or explain to them. You do this, this is what you're going to get. Clear ramifications to their decisions, right? Because it usually means larger equipment, sometimes smaller equipment, but usually larger equipment, right? So knowledge is king in this industry. So if we look at a competition pool, if we look at a recreational pool, they're actually the same pools. The pool is just used in a different way. So typical recreation pool where you've got, you know, 200-300 kids in it, you take the kids out, you put 8 people in, you get a starter pistol and say, go. Well, it's the same pool, right? But now all of a sudden it's a competition pool. But look what happens to the activity factor, right? There's a huge difference. It actually has the same activity factor as elderly swimmers. Now, I'm not saying the Canadian Olympic team, you know, is swimming around like a bunch of old ladies. What I'm saying is, right, this is the average activity for that type of pool. So you take a small pool with a couple of people, you know, moving around. But a small pool, you have a certain amount of undulation of the water. You take a very large pool, right? A very large pool, but you only put a certain amount of people in. Even those 8 people are swimming like mad. What's happening on the other side of the water? It's barely even moving. So again, it's the average of the whole body of water, and that's important. Hotels, elderly swimmers, you know, I mean, this is important. This is an important segment of our population because a lot of times the temperatures are elevated, air temperatures and water temperatures, right? Assumptions could be made in that might not necessarily be the way they want to run their pools. So again, owners' expectations are very important. Any questions on this? Pretty straightforward, right? A bunch of numbers. So, knowing your activity factor is extremely important, right? If you would have guessed this activity factor at a 0.5, which would be a complete body of water at rest, right? You'd be wrong. Now, I think my favorite part about this slide is just the sheer human biomass, you know, on the deck waiting to crawl into this water.
They're waiting?
Hmm?
They're waiting for these guys to
Yeah, that's right, yeah. One thing I can tell you, there's not enough free chlorine in the universe to get me into this. I'm just saying. So actually a pool is a lot like a pot of water, right? You put heat into it, and the way that heat dissipates is through the water evaporating, okay? Now, with an indoor pool, obviously you've got earth all the way around, or you have something all the way around. So really the only way that it cools down is through evaporation. So we'll look at an example here. This is a really large pool, right? This Olympic-sized pool. Our water temperatures are extremely low, right? I think even Canadians would find that water really quite chilly. But the water temperature is going to be consistent in both of our examples here. So it really, for a large part, it doesn't matter. We change our numbers, but the example will still hold true. In our first example, we're going to take a relatively cold air temperature. 79 degrees, you know, for a pool. If you're getting out, if you're not swimming vigorously, when you're getting out, you're going to actually feel chilled. It's not going to be super comfortable. Gives us a dew point of 58 degrees. We're having an activity factor of 1, 490 pounds of evaporation, or 510,000 BTUs is what this pool is losing every hour. Okay? So, now the owner comes to you and says, how am I going to save money in this pool? Right? I need to drop the cost of operation here. Well, the answer is obvious. You're going to raise the air temperature. Well, it's not obvious at all, right? That's completely counterintuitive. When I was cold in the summer, you know, in the winter time, my dad threw me a sweater and said, hey, put this on, that'll solve your problem because it's coming down further, right? That's how you're going to save energy. When a pool, it's a little topsy-turvy, okay? So by raising the air temperature, this is why I'm telling you how you're going to save money. we're affecting the largest heat sink in that building, okay? So your heating losses and your cooling losses, they're going to be different depending on the time of year. But your pool losses are going to be consistent throughout the year, right? As long as the air temperature and relative humidity above the pool are the same, your evaporation is going to be the same. So right there you have an opportunity for huge changes, possibly, right? And good dollar savings. So let's just say we're going to raise the air temperature by 3 degrees. Since it's my presentation, I get to pick degrees. Okay. So we're going to do that. We're going to bring it up to 82 degrees. What we've really changed is we've changed the dew point. So remember in that equation we had the vapor pressure differential, right? So now all of a sudden we've taken that vapor pressure differential that we had in example 1 and we did this to it, right? We dropped it. So as a result, we go from 490 to 425, from 510,000 BTUs to 450,000, okay? So we've actually got a huge change, 60,000 BTUs, right? Twist of the wrist. Now, again, this is every single day of every single month of every single year, right? So this is good economics. The thing I haven't even told you is you probably dropped the unit size by doing this. Now, flip side of that, right? If I went into this application and I made an assumption, well, it's going to be 82 degrees, right? But really, they're going to be running it at 79. You've got the possibility where you're picking, equipment that is too small. Again, it comes back down to knowing your owner's expectations. And you're going to see a theme through this whole thing, by the way. Okay, so we take the last couple of slides, you throw it into a blender, and you come up with the rule of thumb, where you try and keep your air temperature 2 degrees warmer than your water. That helps to suppress evaporation, keep things more economical. That does not mean, and I get this all the time, that does not mean that you can, you have to have your air temperature warmer than your water. You can have it at whatever temperature you want, but there's a price to be paid for it, right? And it's either going to be less operating costs or more. So, you'll have to make that decision. But if you want it to be less, typically it's 2 degrees warmer. Now there's an upper limit to that, okay? You don't typically want to go higher than 85-degree air temperature in a pool. You can, right? And there's a lot of facilities that actually do that now, especially when they have smaller kids, swim classes and stuff like that. But if you look at all the literature and everything, you'll be hard-pressed to find anybody that recommends, 85 degrees and higher than 60%. So that's kind of the upper limit. And for Americans, being in a litigious society as they are, they have a tendency of watching that line. Okay, we're going to talk about condensation control. So if you're going to haze out in any portion of this presentation, don't make it this one. This is the important part. Okay. So we have to remember we've got a 62-degree dew point or somewhere around there in this pool. First slide over here. Can anybody tell me where this is? Anywhere in North America? Of course you can't tell, right? You can't even see through the windows. Now, everybody thinks, this is someplace northern, which of course are right. This is the northern part of Atlanta. Okay? So, if you're going to have condensation on the windows in Atlanta, of course, that it's going to happen here. Some people will say, hey, you know what? Throw better glass at it. Right? I have yet to find triple pane window in a pool. Right? I know what happens. I just haven't seen it with my own eyes. Right? I've only been to about 3,000 pools. So, it's going to happen one day. But you throw a triple pane window at a pool, and your inside surface temperature will still, in our climate, will still be below our 62 degrees. You're still going to have condensation. There's different ways of handling this condensation. We actually have the guy that took this picture. Victor's over here. About 500 years ago. Sorry, Victor. But there's different ways of doing a pool. You're not going to find this method in our literature anyways.
That's nice, actually.
This is kind of the trifecta of bad indoor pool design right here. Okay? So you've got your condensation removal device. Okay? And just so this is sinking in there, this is the inside of the pool. Right? I actually had an engineer ask me, and of course he was joking, at least I hope he was. Do you think that was specified? Oh man. I never thought about that actually being before that day. So we've got this gutter underneath the window. We've got a suspended ceiling. We've got mold. And we have an unprotected rusting steel beam in the corner. I usually say, how do you get better than that, really, but how do you get worse? Usually there's somebody who tries. So keeping condensation off windows is actually super easy. We do it every single day when we're driving to work in the winter time. What do? You turn the fan on and you blow nice warm air on the window. What are you really doing? Right? You're warming up the inside of the window so that it's above the dew point. That's all you have to do in a pool. And don't forget, you've got air temperatures of 82 plus degrees. So even if I took a fan, put it on the deck over here and blew it at this window, right? As long as I have enough air, I can warm up that window so the condensation goes away. So, effective and easy way of doing it. Usually, of course, the easiest way of getting the air is from the equipment. It's kind of a no-brainer. And as long as you have somewhere between 3 and 5 CFM per square foot of glass, right, you're in the hunt. Now, skylights, which I absolutely hate in pools, but skylights are a little bit more difficult to keep clear, so throw at least 5 CFM per square foot, on them. Most of the times, architects will say, well, we don't like the look of the ductwork, so we're not going to bring any ductwork up to the skylight. So, which typically at that point we say, well, just make sure your skylight is right above your pool, so that when it drips into the pool, right? But there's going to be, right? I mean, every decision, there's some sort of ramification, right? There's going to be a lot of damage to this drywall and everything around it. So, condensation is important to get rid of because there's a lot of remediation that usually has to go on if it's not taken care of.
Excuse me, with 85-degree indoor temperature, if you have a high ceiling pool, because we're going to see stratification, still you will see condensation at high level?
Guaranteed, yeah. Yeah, absolutely. It's a good question. But yeah, I mean, and once we get into moving air around in pools as well, you'll see, but there's always going to be some sort of stratification. But no matter what, yes. Okay, so question period over here. You can't see the ductwork, but my question is it 1 diffuser or 2? Right? Nature's pretty cruel. And this is really not even that cold of a day. But you can see that we're not getting the right amount of air. Now, one nice linear slot diffuser, whether it's from the bottom or the top, it's irrelevant. But one nice slot diffuser covering the whole window, and make sure that your throw, if it's coming down from the top, is making it, all the way to the bottom of the window. The reverse is true as well. But at least when you're blowing air from the bottom, especially in the winter time, it's nice warm air and it, helps it travel up the window as well. But one thing you can't see in this picture is that the temperature and the relative humidity is spot on, right? Owner walks in, this is residential. Owner walks in, this is what they see, right? Probably the first words out of their mouth is, dehumidifier is not working, right? But it actually is. This is purely a function of airflow, right? Nothing else. So we're going to talk a little bit about moisture migration prevention, right? This is super, super important if you actually want your pool to keep standing. Okay. Now this is a fabulous shot. This is out in Minnesota. Really cold day. Rarely do you ever get to see the effects of that vapor pressure differential between inside and out. Okay. Normally it's invisible to the human eye. Now, there are absolutely no fans behind these holes, right? That's all they are. They're just vents going through it, non-powered, and it's just the vapor pressure differential, as I said before, between inside and out that's pushing this humidity through. Now, these are blocked up, the outside air and exhaust were controlled as they should be, okay? But it's a good opportunity to see what actually happens. So if we look at a pool, we can see that, especially in the winter time, we have a much higher vapor pressure inside than we do out. Moisture naturally wants to travel from the inside to the outside. Well, let's think about this in the summertime, okay? So if it was the summertime and there's a small window where the humidity or the vapor pressure is higher outside than inside, and that moisture wants to travel through the wall coming indoors, do we care? Right? Do we? Not really. Why? Because at no point in the summertime, if that moisture is traveling through the walls, are we going to hit our dew point? Right? So no harm, no foul. However, in the wintertime, you can't say that. Because this is our inside over here, right? If this moisture travels through the wall, eventually it's going to hit this point where the dew point manifests itself, whether it's in the insulation or whatever member it is, it's going to turn back to water, right? And if that's your wall, that's not such a cool thing, right? That's where a lot of damage gets created. Now, putting in a vapor barrier in a building is, if you look at the dollars of how much it's going to cost, it's probably one of the least expensive things that you're going to do for that pool, right? Probably the price of, a second set of ladders and a diving board, and boom, you've got a vapor barrier. I'm making light of it here. But the reality is, it's going to be one of the most important things that gets put into this pool. Because that vapor barrier will keep the humidity on the inside, not allow it to travel through, and you won't get condensation, right? You won't have your wall destroyed. Now the very same thing is true, of course, of your ceiling or your roof, right? We want to have an envelope that completely encloses this pool where moisture stays inside. The equipment can keep the dew point control, and the walls aren't affected by the humidity transferring through it, okay? Super, super important. We see this all the time. Now, remember I mentioned it's important to do it for the roof as well? Well, that's the point that they missed here. So, apparently, there's a vapor barrier in the walls. Moisture is traveling through the ceiling, hitting all the beams, water's rolling down, and eventually the hydraulic pressure is just pushing through the walls. Okay? Obviously something has to be done about this. So, we can't talk about pools without talking about indoor air quality. We can't talk about indoor air quality in pools without talking about pool water quality, right? They go hand in hand, right? What is causing the indoor air quality in a pool?
So you rather to maintain pool in winter time under positive, negative, or neither of them pressure? Positive to pressurize it, or negatively?
We're going to get to that a little bit later, but the answer, at the end of the day is you want negative inside the pool, right? Anything has to infiltrate in, not exfiltrate out. So, when we're talking about indoor air quality, we're talking about, what affects our indoor air quality more than anything else, right? And that's going to be the off-gassing from the pool, right? Super important. A lot of people, and I'm sure at one point I said it, you walk into a pool and you go, ooh, you can smell that chlorine. You're actually not smelling chlorine, right? What you're smelling are chloramines. And chloramines are a byproduct of typically underchlorination. Okay? So that's a little bit of irony there for you. But if you are actually smelling chlorine, you could probably measure, you know, the rest of your life on the second hand of your watch. Okay, you'd probably be at a lethal concentration, and since you're all here, it wasn't for me. Okay, so pool water chemistry is super, super important, right? A lot of people are taking some very drastic and very necessary steps to make sure that pool water chemistry, you know, is taken care of. And you know what? We know a lot about it. We're not experts in it. Pool water guys, they're the guys to talk to. You know, there's a lot of UV going on. There's a lot of different things that are helping, you know, with this. It's a super not only just important, but it's also a really interesting field, right? Now, you walk into a pool and you just smell that. There's a whole bunch of assumptions that you can make, but typically not a good idea. There's a lot of things that can affect that chloramine smell, right? Is it bad pool water chemistry, or is it something else? Well, really, on the equipment side, there's only two things that we can really affect, right? We have no control over the pool water chemistry. We really don't, right? But we do have some control over the amount of outside air and the amount of exhaust air, right? And this is going to get to your whether it's negative or positive. So if we look at what ASHRAE recommends for the outside air, it's actually quite simple. It's 0.48 CFM per square foot of pool and deck area, plus you add 7.5 CFM per spectator. Okay? Now when you're talking about spectators, we're talking about people that are wearing clothes. Right? We're not talking about swimmers. Swimmers are wrapped up in this square foot number. Okay? Now, when it comes to spectators, let's say you have a large facility and you could possibly have 300 or 400 spectators within that facility, right? You're not having 300 or 400 spectators in there every day, all day. That's not the way it happens, right? You're going to probably have, at best, 3 or 4, maybe if you're lucky, 5 swim meets where you're going to have that many people in. So it makes sense that you have this portion, that metered amount of outside air coming in only when you have the spectator event. Have it on a time clock. Have it on something that will shut it off when you don't need it. Because outside air is super, super expensive. And not just for the thing that, you know, pops into our head, right? Well, pool is 85 degrees, I mean, you know, outside. You're talking about like, you know, 90, or depending on where in the country you are, 90 or 100 degree delta T between inside and outside in the winter. That's obvious, right? But if you go back and you think about that example of that large pool, where we had 450,000 BTUs of latent heat coming off of that pool, right? If you're bringing in a lot of outside air, right, you have the possibility of losing a huge chunk of that latent heat. Now, I'm certainly not saying to cheap out on these numbers, right, because that would be a huge mistake. But just, you know, figuring out what your number is and then doubling it, well, again, there's a price to be paid for that. Outside air is going to be super, super expensive, right? And if you think you're going to be doing a great job as far as air quality goes, right, probably not, because in practice, these numbers do a really good job, right? But they have to be in conjunction with all the other things that we're going to be talking about. Right? There's no one solution. The whole system has to be built properly. Any questions so far? Anybody notice this down here? Right? There's no real recommendation out there for water parks. Okay? So pool water chemistry 101 is you've got a body of water. Free chlorine is the amount of chlorine that's in the water that's not being used at the time. Okay? And little Johnny or Susie jumps into the water, maybe they didn't take a shower, they got body oils and maybe some other stuff. Well, that free chlorine is supposed to sanitize that, right? It's kind of like troops waiting to go into battle, okay? So if you don't have enough free chlorine in your water, and the reason why I'm going into all of this is think about water parks. Lots of kids. How deep is the water? that deep, right? So there's not a lot of free chlorine in there. So there's a lot of off-gassing of chloramines. So at that point, you're looking at bringing in more outside air just to do the right thing, okay? But this is not a hard number, right? This is a number that's been learned over many, many jobs. ASHRAE doesn't give us a recommendation on that yet. We also have to talk about exhaust air, okay? And if you want a number, it's going to be, negative to 0.05 to 0.15. If you're looking for a rule of thumb, it's 110 or 115% more exhaust than the amount of outside air that you're bringing in. I always recommend that people actually do the calculation. You can have, especially on retrofit jobs, where fans are going in, replacing the ones that were there before. Your hallway could be significantly negative to your pool, even after putting in your rules of thumb, just because all those air handlers and what have you outside of your space were thrown in but never balanced. Okay? So a little bit of safety here is not a bad idea, or the ability, to ramp it up if you need to. Questions? No? Anybody ever walk into a large facility and go, oh, hey, there's a pool in here somewhere, right? Yeah, well, they don't have it negative, right? So they missed this light here. So maybe we'll just send it to them. The only way you should know there's a pool in the building is follow the signs. Right? Also, when we're talking about chloramines, the worst offender of that, the one that really burns your eyes and burns your nose, actually burns a mucous membrane, right, in your lungs as well. Anybody ever hear of something called swimmer's lung, right? Lifeguard's cough, right? It's all really the same thing. And what it is an exposure, an overexposure to these chloramines, okay? Chloramines are 4 times heavier than air. So if you think of a bathtub, where does the water go? To the bottom of the bathtub, because it's heavier than the air that's in your bath, right? The same thing happens to the chloramine. So we're all really lucky they go down, okay, to the deck area where our kids are breathing. So we need to make sure we do something about that. So there's a lot of different ways of doing that. Let me go back one. Source capture is an idea, okay? And source capture is basically just like, you have a welding station, you've got exhaust right above it, you're exhausting those welding fumes right where they're happening. In the case of chloramines, they're coming off the pool, they're staying down on the pool deck, so exhaust's down low, right? There's manufacturers that make stuff like that, where you can exhaust right from the deck, right in from the gutter as well, right? And that's a good choice. Something to think about. It can make the difference in pools that are considered bad pools, right? Usually somebody just missed 1 or 2 of these slides, and the reason why it's a bad pool. It can be fixed though. So one of the ways to also help in this, right? We've got the amount of outside air, we've got the exhaust, we're talking about source capture here, but we also have to move a certain amount of air around in this space, right? What are we trying to do? We're trying to get air moving, getting air down into the breathing zone, moving these chloramines around so that the air that we're breathing is much better, okay? And you'll find, like in the bad old days, people would have these outside air systems, right, that brought in X amount of outside air. They would keep the relative humidity in the space, whether they were economical or not. Typically in this part of the world, the answer was no. But were they good pools? Most of the times the answers were no. Not because the relative humidity wasn't being kept, but because all they focused on was the amount of outside air to control the relative humidity. They never thought about this, and they didn't get the right amount of air changes, and they never got that outside air down into the breathing zone. So if you were up on a ladder 15 feet in the air, you're going, oh, this is great, right? But if you're swimming in the pool, not so much. Because you didn't get these air changes. Now, ASHRAE is recommending between 4 and 8 air changes in this space. And again, big point, get that air down into the breathing zone. Because if you're bringing in that outside air, but it never gets down to your swimmers and you never push those chlorines out from the pool deck, you're not affecting change and you're not going to have a good pool. Good pool. Questions? Hopes, dreams, aspirations? Okay. Supply and return locations. There's a number of different ways you can do this. Most designers, when they have a pool and a drawing in front of them, right, they're looking at breaking all the rules and everything's an exception. Because sometimes it's not easy, right? Most of the times it's not easy. Supplies, I mean, we talked about supplies. We want to get air on exterior windows. We didn't talk about exterior doors, but that's super important, right? Think of a cold climate, condensation on your fire doors, and eventually freezing it shut. I suppose there's a case saying, well, the fire will thaw the door out, but I'm not so sure the fire guy is going to agree with that, right? So blowing air on that door is like a really good thing. You also got to make sure that in those windows and in those doors that there aren't any thermal bridges, right? Because if there's a thermal bridge in there, you can blow as much air as you want, you're still going to have some sweating. Okay, so that's important. So you want to make sure that your supply is covering all of your windows, but you also want to make sure that you're getting a nice airflow pattern within the pool. You also want to make sure that your return complements your supplies. And nowadays, more often than not, people are putting returns down low. One of the reasons is to help those chloramines be moved off of the deck and circulated through the space, right? Spread it out so that you don't have bad pockets of air. I went into this one pool in Michigan, and you walk in and you go, "Ooh, this is beautiful." And it was a crazy pool. They have one of those where they have slides that go outside and spin around 50 times and come back in, and glass everywhere, glass between the two different pools. And as you're walking through the thing, and I was really, because this is what I think of when I go into a pool, right? I'm thinking about the air quality, I'm looking at the ductwork, there's no condensation, it's all really good. And when we're done, and then we leave, we actually left through the door that nobody ever goes through, which is the front door to the pool, right? Everybody's in and out of the locker rooms. We happen to come in through a side door. So we go out the front door, and it's kind of like a tunnel that's going underneath the stands. And it was like going through a gas chamber, right? Every chloramine that was in that pool was in that tunnel, right? It was horrible. It was like the next 2 hours, my eyes were sore. So, which tells you that airflow is key. Now, obviously, nobody was thinking, oh, let's put some diffusers in this tunnel, right? Nobody cares about that tunnel. But you do care about the whole building. So you've got to think about that when you're putting in supplies, right? And when you're putting in returns. So we talked about getting air, into the breathing zone, get it close to the pool. We want to make sure that we watch for short circuiting, okay? I see that in just about every pool that I go to, okay? Where you've got your return here and your supply diffuser right up here, right? Boom, short circuit. Happens all the time. We gotta get rid of that. So there's different ways of getting air into the breathing zone. Now, this is really important, right? Whether you choose supply ductwork that's in the deck or above, right? You do not want to blow air directly on a pool. You buy coffee in the morning and it's too hot, what do? You blow on it, right? You don't even have to know why. You instinctively blow on it, you know that it's going to cool this liquid down, right? You're increasing your activity factor essentially, right, on your coffee. Now you're never going to be able to have a cup of coffee without thinking about activity factor again, right? But you're increasing your activity factor on this cup of coffee so that you're going to cool it down, right? But if you're increasing your activity factor above what you figured it was going to be for your machine, you'll never ever be able to hold the relative humidity in that space, okay? And you're going to cost a lot more money. So typically you can have about 10 to 30 feet per minute of air being induced across the pool. That's part of having the activity factor that you have, okay? And it also keeps it comfortable. You do not want a whole bunch of wind going across the surface of the pool, right? Nothing good can come from that. So if you've got your ductwork above, you can help to induce that airflow. It's when you get to really super large pools that becomes difficult, especially in the interior portion of the pool. There's ways of doing it. If you had your ductwork in the deck, you can also help induce an airflow across that pool, okay? And again, everything comes down to making sure that we're getting those chloramines off of the pool and off of the deck, and that we're keeping that air in the breathing zone sweet. Are we good with air quality? Anybody have any questions there? No? Let's transition over into ductwork. Different types of ductwork from different pools. You can imagine over many, many years you see all different types. And the one ductwork that you'll see the most, especially in old pools, is galvanized. A good galvanized G90 duct holds up for many, many, many years. And people, like, you tell them that, and their mouths open up, it's like, really? That's what you would think? Well, there's all sorts, right? I mean, you can have, painted galvanized, as long as it's a good quality galvanized G90 or above, right? It will last for many, many, many years. Aluminum will do a good job, a lot more expensive. Fabric duct, does a great job as long as you make sure that you have the throw down your windows. You get the right diffusers, that you've got solid air, getting on there. Just a regular fabric duct with a bunch of holes punched in it does not mean you're going to get the right airflow, right? Airflow is key, so that's an important thing to focus on. It's also really good for retrofit applications, where you might have a 40-year-old pool, and when they did the design for that pool, maybe they followed the recommendations, maybe they didn't. But now it's time to fix that, right? Fabric duct is typically an economical way of being able to do that. In an indoor pool, the fan is running 24/7, so you never have to worry about the ductwork deflating. So that's another big positive. I always say avoid stainless steel, right? It's completely counterintuitive, I know. This duct was out in Nova Scotia. This is actually 8 months after they put water in the pool, right? 8 months, that's it. So I've got a picture before, I got a picture of after. And I know, because I was there, this is stainless steel 316L. Okay, so it's not inexpensive. The owner would say it's cheap, but it's not inexpensive. Okay, so it's been about 2 years now, and I would probably wager that there's enough holes there the size of my pinky to be able to get some extra air going across the ceiling. Okay? And that's expensive ductwork. That's probably not what the owner was looking for. The stainless steel doesn't work so well. Heating and cooling. Whenever we're factoring in heating and cooling, we got to remember that this space is typically 10 to 15 degrees warmer than a normal space that we would design for, right? Super important when, typically you're talking about more heating BTUs and less cooling BTUs, okay? Typically, especially in this part of the country, if somebody's coming to us and say, yeah, we need a lot more, sensible cooling, like, not so sure. Maybe you figured this at 72 degrees as opposed to 82, right? That's always a possibility. But you also got to factor in the amount of outside air, right? You could have 50% of your heating load just being due to outside air. Now, this picture came from Boston. They're used to having fog in Boston, but usually it's outside, right? And if you're interested, the lifeguard is standing right there. Okay. So what happened here, right? It's really simple. They didn't factor in the amount of outside air when it came to their heating load. So when it got colder outside, well, it started getting colder inside. When it got down to the low 70s, right? What happens to the evaporation when the temperature goes down? Evaporation goes up, right? The thing we didn't talk about, you know, is that the moisture removal of the machine is going down. Okay, so somewhat of a problem. So eventually, of course, they had to close the pool down because if the lifeguard can't see to the bottom of the pool, she actually couldn't see to the surface of the pool either. But if you can't see to the bottom of the pool, you know, you can't save anybody's life, so they have to close the pool. Simple remediation is they put a duct heater in the outside air opening to take care of that load. But of course, after the fact, somebody had to pay for that. So we also got to talk about energy recovery, and in this case, we're going to pick on mechanical dehumidification. Energy recovery is an easy one, right? With 100-degree delta T, as long as you have a decent amount of outside air, if you're talking about 100 CFM of outside air, your heat recovery is probably never going to pay for itself. If you have 2, 3, 4, 5,000 CFM of outside air, it's just plain and simple a no-brainer, right? If you can get at that outside air and you can get at your exhaust, you've got a great way of saving a bunch of money. Right? Let's also think about dehumidification itself, right? So, what's the pool doing when it's cooling down, right? There's heat being released. It's latent heat. That latent heat, the humidity that we're trying to get rid of, you bring it through the refrigeration system. And once it goes through the refrigeration system, you've trapped all that heat. You've trapped the sensible, you've trapped the latent, and you can do whatever you want with it. So, take that heat, put it back in the pool, now you have yourself a thermal flywheel effect, right? And that's how you save money in the pool. So if we look at this, if we look at the psychrometric chart over here, right? And if we follow a molecule of air as we're going through the evaporator coil, we cool it down until we finally hit the dew point, right? Or the saturation curve. And we keep cooling it down, right? And we're leaving the coil somewhere around 50, 52 degrees, somewhere around there, okay? What have we done? When we've done that is we've removed all that latent heat, right? And we've removed all of that sensible heat. So that total heat that we've done, that work, is over here in our evaporator coil. So this is our vapor compression cycle, okay? So our evaporator coil has done all this work. We've retrieved all that heat. And then we have to run our compressor to boost up that pressure. This is what we're paying for, right? We're paying for that compressor to run. So by paying this, we get all of this back, okay? And that's how you can make it a lot less expensive to run, to run a pool. So all this latent heat that came off of the pool, you can take that and through a water to refrigerant heat exchanger, put it right back to the pool. A byproduct of dehumidification is heat. So use it. Just about every week someone will come to me and say, well, they don't really want to put in the pool water heater. It's like, well, why? Right? It's a great opportunity. Like, well, in the wintertime, if the compressor's running, we can use all that heat in the space. They're absolutely right. But they're not thinking about the summertime, right? In the summertime, even when you're in full cooling, okay, do you want to just take all that heat and throw it outside? Or do you want to take this big portion of heat, heat up your pool, right? Get every last BTU that you can, heat up your pool as opposed to throwing all this heat away and then running a gas heater to heat your pool. That doesn't make any sense. Use it, right? You save a lot of money per year, right? And it's not a big cost of the equipment at all. It's an insignificant cost. So it makes sense. Questions? No? we've gone through all of these. Does anybody have any questions on any of these bits and pieces? I know there's a lot of information there, right? But anybody? Excellent, excellent, great.
Yeah. One of the purposes of the equipment is to dehumidify the space. We have a lot of hours here that are cold and dry. Can you just use an economizer cycle with these types of things?
Depending on where you are in the country, right? There's some spaces, especially the further west you go, when the amount of outside air that you need to bring in by code is enough to dry out the space. In that case, it just makes sense anyways, because you're doing it, right? Reality is if you're increasing the amount of outside air past the amount that you're recommended to bring in, you're going to end up spending more money than you will saving. Okay? If your minimum amount is doing the dehumidification, your compressors are going to shut off anyways. But then when you turn around and you got the shoulder seasons and all summer, right? That's where you get to recuperate all the heat that's coming from your pool. So if you look at that large pool, if you're taking 450,000 BTUs on your best day of the year, let's say it's 82 degrees inside and it's 82 degrees outside, right? Some people would say that's a free dehumidification day. It's 50% as well, right? So you got like the best condition ever, right? Free dehumidification is only going to cost you 450,000 BTUs. So I don't know if you really would call that free. So if you do the economics in our part of the world, typically no.
Well, in Ottawa, we have shoulder season. We have days that they're cool but very humid. Rainy days, it's very cool. So bringing that many outdoor air might not be even helpful because you're adding moisture to the space.
Typically, if you run the analysis, you'll find that an economizer will save you money in certain parts of the year, right? But the amount that you save usually doesn't pay for the extra cost in the equipment. Now, that equipment, most of the time, what you use for an economizer, right? Extra exhaust fans and bringing in that extra outside air, that serves another purpose, what's typically called a purge, right? When you're superchlorinating the pool and you have a lot of off-gassing of chemicals from the pool, right? That's a perfect opportunity to use that, and that makes sense to put it in for that reason. If you're putting it in, figuring that you're going to save money in an economizer cycle, probably not.
Just further to their questions, what are you typically doing with the water to recover within the equipment?
That is probably my favorite question that people ask me, right? If you look at the amount of moisture that comes off of a pool, it's typically one pool fill a year, right? So I think officially that's known as a crap load of water, right? So, I mean, it's a huge possibility for savings. In a lot of parts of North America, it's against code to put that back into the pool, right? Which is really a horrible shame because if you put it in before your water treatment, right? Typically, and all the studies that I've ever seen on equipment that's been maintained properly, the water quality of the condensate coming off of the unit is better quality than drinking water typically, right? Less chemicals, and I don't know if you know, but chloramines are being used to purify that water. So you're adding more chloramines into the system, and if you remember, chloramines are what we're trying to get out of the air. So it's a perfect opportunity to recycle a bunch of water.
At the beginning of your presentation, you provided some ways of estimating the dehumidification with respect to departures and stuff. What's your take on these sort of leisure pools that are really rich with these water features?
Oh,
you
yeah.
An approach you like these to approach these?
Yeah, absolutely. Typically, when it comes to that, we break down each water feature. There's an activity factor that gets applied to each one of them. Because usually when you're talking about a very large aquatic center, they're very dynamic, right? The drawing that you get with the water features that you have on the drawing at that time you're almost guaranteed that most of it's going to change by the time it actually gets built. So isolating each one of your humidity sources and making sure and following up by the end of the application that they're all there, they haven't changed, they're all the same size. You've got to control it, because there's a lot of humidity that can come off of those things, right? I mean, you got all sorts of cool things, right? Like a Tahitian village with a 1,000-gallon bucket of water that dumps over, spray cannons. There's all sorts of really cool things out there. Any other questions? Good.
Where do saltwater pools come into play here?
As far as dehumidification goes, it's one or the other. It doesn't really matter. A non-scientific answer to that is most saltwater pools that I go into, a saltwater pool is still a chlorine pool, right? There's just a generator in there that uses the the chemicals that are in the water to produce chlorine, right? But typically those environments are less harsh than pure chlorine pools. If you talk to pool guys, they either love them or hate them. I haven't found one yet that's somewhere in between. Right? One thing that's more important when it comes to saltwater pools is bonding. And bonding is to make sure that the voltage, there's no voltage differential between the deck, the ladders, and the plumbing and piping and pool water heaters, right? They're all bonded together, so everything is at the same voltage, so that there's no galvanic corrosion, right? That's super important. Every once in a while. Every once in a while. But it's not really in that wheelhouse, right? A little bit more difficult for them to, just compete, really. Again, non-scientific answer is I don't know how well those chemicals hold up to chlorinated environments. Any other questions? Excellent. Bryce, thank you very much.
Who's the better goalie, Leonard or Anderson?
Oh, it's Leonard. Next question. He knows I hate Anderson.
So I'd like to take this opportunity to present Mark with a token of our appreciation. He's really good.
Thanks very much.
So, thanks again to Mark for pinch hitting, guys. I think it was an excellent presentation, one that's applicable for a lot of processes, a lot of opportunities for us here in town. We do have the advantage of a local manufacturer, so that's always a great resource to have. Next month, we are going to be back in the same place, third Tuesday of the month. Things happening between now and then. Remember the bowling. Please remember the seminar as well. Both those items can be signed up for online. But with that, I'll thank you all for coming and bid you a good night. Wait, one more thing. Dan Redwood would have my head. Everyone who registered for the event, we have your email address. You'll be emailed a very quick survey, a 3 or 4 question survey online. Please take a couple of minutes, fill it out. It helps us determine how things go for meals, for speakers, for venue, helps us plan for years to come. We want to make sure we're giving a program that people enjoy. So just take a few minutes out of your day. You should have that tomorrow. If you can fill that in for us, it's greatly appreciated. Thank you.
There we go.
Nice to see you again.
See you again. Take care. Stories. That's and then the old slide.